Before answering these questions, maybe it's better to review the electric field. If we consider charge of the Q, electric field actually is generated by this existence of the charge of the Q's. The magnitude of the electric field is dependent on the distance from the positions. So in this case, if we consider the electric field at this position, the magnitude of the electric field is E is expressed 1 over 4 pi epsilon naught times Q over R square. And the directions, electric field is a vector quantity. It should be expressed in vector forms. So in this case, the R vectors over R, you have to multiply. This is a unit vectors. Magnitude of the unit vector is 1, so it has just only the directions. So direction of the electric field is directed outward from the charge of the Q's. So this is electric field. Electric field in the component forms. So in this case, we consider the x, z coordinate. And the charge of the Q is located at A from the origins on the z-axis. This is A. Then we'd like to consider the positions from the centers, origins on the x-axis, x. Then you can consider these triangles. You can use the Pythagoras theorems to find out the distance. This r is expressed the square root a square plus x squared. And the magnitude of the electric field, this electric field magnitude, E, this E, magnitude E, is expressed 1 over 4 pi epsilon naught times Q over R squared. So this E vectors is expressed sum of the two vectors. So E sub z times k. K is a unit vectors, and k is a unit vectors directed to the z-axis. So this is E sub xi. So E vectors is expressed, so E vectors can be expressed E sub xi plus E sub z k. So in this case is E sub x. E sub z is we call the component. Then we'd like to express the E sub x as a magnitude of the E. So E sub x is a projection if you consider these triangles and these triangles. Exactly, it's not same, but it's similar. So ratio of the two sides same. So E sub x over E. If you consider these triangles, compare these triangles, say E sub x is correspond to the x. So it should be equal x over E correspond to this R. Could do the same things. E sub z over E. E sub z is correspond to here. So that's correspond to A. So E sub z is A over R. So from these two equations, you can find that the E sub x is E times x over R. E sub g is E times A over R. So you can substitute magnitude of the E. Then we could express this is 1 over 4 pi epsilon naught Q over R cube x E sub g is 1 over 4 pi epsilon naught q over r cube z. So this is, you can substitute the E is 1 over 4 pi epsilon naught q over r cube a. So we discover the actually the x component of the electric field and the z component of the electric field. Then we'd like to consider the more complicated situations. Now, so in the previous case, we just only consider single charge is located on the z-axis from the origins. So we'd like to consider two charge and the same amount of the charge of the q, lower case of the q's. And then one of the charge is located in the negative a, and the other one is a positive k, z-axis. Then we'd like to discover the electric field produced by these two charges. Then on the x-axis, then as I explained, this is electric field is produced by the one of the charge. So if you like this is two charge, and the other charge also produce the electric field E. So if you consider the sum of the electric field of these two, so if you consider this is E sub 1 and this is E sub 2, this is charge 1, this is charge 2. So we'd like to find out the sum of the total electric field should be a sum of these two vectors. So from the symmetries, actually electric field of the should be the sum of these two. E sub 1 x, E sub 1 z, this is E sub 1 z. But as you really easily imagined, E sub 1 z, and this is E sub 2 x, and this is E sub 2 z. So total E is expressed E sub 1 plus E sub 2. This is E sub x plus E sub 2x I plus E sub 1z plus E sub 2z k. But as I explained, this should be become 0 because these two vectors has the opposite direction. So this is becomes twice times E sub 1x. So from this equation, you can find the answers of the E. It becomes 1 over 4 pi epsilon naught 2q over r cube times x, because we substitute this E sub x. These equations we use and substitute into this equations. And if you substitute r equal square root x plus x squares, this equation is expressed 1 over 4 pi epsilon naught 2q over a squared plus x squared over 3 over 2x. This is the equation. Okay. Then we would like to consider, try to solve these questions. So we consider the ring. Ring is placed on the YZ planes. So ring on the YZ planes. So ring is placed on the YZ planes. And then we are going to this ring is divided into the number of the small pieces. Same areas all the positions has. And then if you consider this position and this position, if you want to consider the electric field is produced by these two charges on the x-axis, then from this equation we could find if the two position has the same amount of charge of the q, electric field directed on the x-axis. This should be here, right? So if you consider this, and if you consider another position, for example here, and we'd like to find out the electric field produced by this red ones. But always you can find because of the symmetric figures of the circles, always you could find another charge located in the opposite positions from these red ones. Then some of the electric field also directed on the board. So we could easily find electric field has the directions of the x-axis is directed to the positive x. Then if you look at the original equation, this 2q, this is coming from the sum of the total charge. Okay, so from this equation you can understand electric field has a three component. E sub y, E sub z is going to be 0, and the E sub x is going to be 1 over 4 pi epsilon naught x over x squared plus a squared 3 over 2, and the charge of the qi. I is coming from all the regions. If you sum up all the charge, it becomes the total amount of the charge of the capital Q's. So answer is expressed Q over 4 pi epsilon naught x over x squared plus a squared 3 over 2. This is the answer to these questions.